Hello, my name is Tim Clark, founder of Corazon Oilfield Services. Welcome to Coring 101. This is episode 11, and in this episode I have a special guest joining me, Mr. Colin McPhee. Colin is one of the most highly regarded core analysis experts with a particular focus on geomechanics. Colin has over 40 years of industry experience covering petrophysics, core analysis, geomechanics, formation damage, and sand management. Until recently, he was the global head of rock properties for LRS Energy, advising on petrophysical and geomechanical aspects of field development, asset evaluation, and well construction. He has started a new consultancy focused on consulting and training, Pelican Rocks. He regularly presents at industry conferences worldwide, and he was technical editor for SPE Formation Evaluation. He's also authored several technical papers and taught core analysis and geomechanics courses to thousands of industry professionals worldwide. In 2010 to 2011, he was an SPE Distinguished Lecturer. He received the SPE North Sea Regional Award for Formation Evaluation. He has also co-authored a fantastic textbook that I highly recommend, Core Analysis, a Best Practice Guide. And now, without further ado, I will hand you over to Colin.
My name's Colin McPhee. I'm a director at Pelican Rocks, based in Edinburgh, previously working for LRS Energy. And today's presentation is really the importance of core analysis and its role as the foundation of formation evaluation. So the value of core analysis data. Core analysis data is used in the two principal modelling processes in formation evaluation and reservoir development. Firstly, it's used extensively to determine volume of hydrocarbons in place through key parameters such as porosity, saturation versus height relationships, and permeability. This is a so-called static model in the sense that the core analysis is done under fairly static conditions. It's also used to map hydrocarbon recovery processes, used extensively in dynamic reservoir simulation models. And it's often been said that core analysis data provides the foundation for an integrated evaluation. For example, in the hydrocarbons in place equation, what we're particularly interested in and what we can get from core is net, which is from permeability testing, total porosity, and water saturation. For net, which is mainly a permeability cutoff, there's a number of different test methods available, Klinkenberg permeability, probe permeability, etc. For porosity, we can measure helium porosity and we can resaturate the core samples in formation water and determine its resaturation porosity. For the electrical parameters, for water saturation, we do tests such as formation resistivity factor, resistivity index, and for Waxman-Smith parameters, we need to determine some form of QV. It's also used independently by being able to determine primary drainage capillary pressure. And again, there are a number of techniques available. Three principal tests are mercury injection, porous plate, and centrifuge. And of course, we can get a direct measurement of water saturation through Dean-Stark saturations, for example. Now, core analysis input to oil recovery is principally to do with the relative permeability information. We can get, for example, in an oil reservoir, KRO and KRW endpoints from unsteady state water floods, the intermediate relative permeability curves from both unsteady state, steady state, and if you wish, centrifuge. We also get KRG and KRO, the oil and gas relative permeability curves from these tests. Most reservoir engineering simulation programs require an imbibition capillary pressure. We can get both spontaneous and forced from a variety of different techniques. All mechanisms, though, one of the most important things we need to determine is wettability. And again, there are three main core methods to determine the wettability: AMOT, USBM, and a combination of both. And for depletion drive calculations and material balance calculations, we need pore volume compressibility. For gas recovery, again, particularly looking at gas relative permeability, both the endpoints and the curves from steady state, unsteady state, and centrifuge tests. And again, we need imbibition capillary pressures, both the spontaneous and the forced. So, we assume that core is the ground truth, but we have to consider the uncertainties in the data. And this is an article from Bob Harrison, who's a consultant petroleum engineer, written in 2009, where he said that logs alone can't characterise a reservoir if you don't have knowledge of the rock. Core allows you to confirm the lithology, the mineralogy. We can calibrate our logs with fundamental measured rock properties. It shows how fluids occupy and flow in a pore space. And we also use core for rock mechanics tests, formation damage tests, for completion design and improving the drilling process. And what Bob said is that the predictable consequence of not having core data is greater uncertainty. So core is looked upon as the ground truth. But in my experience, looking at a variety of vintage core analysis reports from all over the world, then generally 70% of scal is deemed to be unfit for purpose. Now that's not necessarily the laboratory's fault. Yes, you can get variable data quality, but most of this comes from damage to the core when you're taking the core, inadequate program planning and inappropriate design of the core analysis program, poor reporting standards, method sensitivity. Different methods give you different porosities, for example. And certainly in some of the vendor labs, lack of investment in people and resources and limited succession planning. And as Albert Einstein said, a theory is somebody nobody believes in except the person who made it. An experiment is something everybody believes except the person who made it. So how do we reduce this uncertainty? And let's look at the situation where we're actually going to be taking core and planning some core analysis. This is really down to three things: design, planning, and ownership. Now, design and planning the core analysis program and the core analysis tests, the first question you need is, what data do we really need? What's the most important? What has the greatest impact on the static model or the dynamic model? Have we got a difficult formation? Do we need specialist preparation techniques so we avoid damaging the sample during the cleaning and drying process? And remember, every laboratory report is laboratory's interpretation of the measured data. It is not definitive. It can be subjective, and in many cases there's certainly alternative interpretations possible, as you see in this mercury injection data set, in which two different pore volumes, which is possible in this measurement, give you two different capillary pressure curves. Ownership. One of the key processes that we get involved in is basically enabling the focal point. That is a person, a geologist, engineer, petrophysicist, whatever, who's the liaison between the labs who are doing the tests and the end users. That's the drilling and completions department, the petrophysicists, geologists, and the reservoir engineers, who all have conflicting aims for the core. The job of the focal point is to liaise between the lab and the end users. That focal point, the responsibilities include identifying and designing procedures for optimum core recovery and well site handling, how we're going to store the core, how do we transport it to the lab, design the test and reporting procedures with the laboratory, reviewing the vendor performance, checking the data in real time, and potentially reinterpreting the data. And when you do this, then what you find is you get a much more proactive approach to the management of this ownership process. Labs tend to become more involved. They see the importance of the data that they generate to the overall field development picture. This is something that many companies have tried. The example here is a core plug history chart, which is a bit like a Facebook for core plugs, which allows you to track the status of any core plug through the whole progress of the core analysis program. And at the end of the day, you can look back through the report and look at that core plug, and perhaps some of this might explain the unusual results that you might get. So, applying this ownership principle, in our experience, gives you a much more coherent and consistent approach to core analysis and its interpretation. The redundancy of the data is cut from 70% to generally less than 10%. There are still exceptions. The labs become more involved and more aligned with the stakeholders. When you get to a redetermination or unitization or an equity dispute, having this information gives you a full data audit trail, so you have confidence in your data, which can often lead to better equity and unitization positions and much less uncertainty in reservoir.
Thanks again to Colin for agreeing to do this guest podcast and outlining the importance of core analysis and demonstrating the importance of having a dedicated liaison with the labs and taking ownership. In the next episode, we'll go back to the overview of coring operations and look at core recovery and processing. Thanks for listening, and before I go, I'd just like to say, if you've enjoyed this video, then please feel free to share it, subscribe to my channel, and also visit corizonoil.co.uk using the links that have appeared on screen.